Hello class, today we're going to talk about comparing and ordering real numbers. Now I know we've already done a lesson similar to this, but this one, now that we've got the calculators for real, we now can really dig into this. So let's take a look at a couple things. Let's just go ahead and talk about this warm-up just to kind of be on the safe side. So this one says, what number sets do the following numbers belong? Okay, so in this particular one, we know we've got a few sets of numbers that we're dealing with. We know we've got the natural numbers. We know we've got the whole numbers. We know we've got integers. We know we've got rational numbers. We know we've got irrational numbers. And then, of course, last but not least, real. Okay, so we know the natural numbers are just our finger numbers. They're just the counting numbers, 1, 2, 3, 4, 5. Whole numbers add zeros. Integers add all the negatives. Rational is any number that I can write as a fraction, so it brings about our decimals and fractions. Irrational is any number I cannot write as a fraction. And then, of course, real numbers are both of them. Both sets of rational and irrational are called real numbers. Now, a couple of things that we need to remember about testing these. Like in this first one, we got a 9. And we want to know what number sets does it belong to. So is it a counting number? Yes. So 9 is a natural number, which makes it also a whole number, which makes it an integer, which makes it a rational number, which then makes it a real number. Okay. Now the next one down here, negative 12.5. Well, it's not natural. It's not counting. It's not a whole number because it's got a decimal part. And it's not an integer, because integers have to be whole numbers or their opposites. So because of this decimal part, this 0.5, it's not going to be an integer, but it is going to be a rational number, and it's going to be a real number. Now for square root of 75, we now have to actually test it. So this is where you actually type it into the calculator to find out what the answer is going to be. So I've got my calculator right here, just like you have your calculator on your desk now. And we're going to type in square root of 75. So we know we're going to hit the second key, hit the x squared key to get the square root up, hit 75, hit the right arrow key to get out of the radical, and then hit the enter key. So what we're looking for, in order for it to be a rational number, okay, if we get a long decimal like we have here on this particular calculator, okay, we're looking for, is the decimal repeating? Is there any idea of repeating in there, okay, or does it stop? And in this particular case, it does not. So that means that square root of 75 is what we call an irrational number, but it is also a real number. Now, the square root of 21, it's got a negative in front of it. So really what that means is whatever the answer to the square root of 121 is, we're going to multiply it by 11. Multiply it by a negative, okay? So let's do this. So we're going second x squared, 121, enter, we get 11, and so now we multiply that by a negative, so that's going to be a negative 11 for my answer. So then based on that, what's it going to be? Well, it's not going to be natural, it's not going to be whole, it is going to be an integer, okay, which means it will then be rational and real. And so that's the number sets. So we will be having a quiz over that in the not too distant future, just looking at those various kinds of things, especially since we have our calculators out now. Okay, so that's what we're looking for. So today what we're going to end up doing is comparing and ordering real numbers. So in other words, we're going to be doing the same exact thing, typing numbers into the calculator, stuff like that, but then we're going to be looking at it in terms of where do those numbers fit on a number line. Okay, so this is our standard. You'll notice it is an 8th grade standard. Order a set of real numbers arising from mathematical and real-world contexts. So here's kind of an example. It says, let's see if you can order from least to greatest the following. So the first thing we got to remember is we got to pay attention to the order in which things are asked for. In this case, we're doing least to greatest. So since we've got integers and decimals, we're going to think about our number line. Okay, so here's our 0, and we do have a 0 in this number set, so we're just going to put that 0 there. And then we just place the numbers on there. You don't necessarily have to put them in any specific distance away, things like that. Just put them in an approximate space. Like this first thing's a negative 5. So here's a good spot for a negative 5. So here's another good spot for an 8. Here's, I know 2 is going to be closer to 0, but between 0 and 8. You got negative 9. I know it's going to be a little further out then -5. -3 is going to be between our 0 and -5. And then -6 is going to be a little bit further than the -5. So now that I have those written, I can write them in anywhere I want to. But since I'm doing least to greatest, we're going to write it as -9, -6, -5, -3, 0, 2, and 8. And that would be my order. Okay. Now, if we're wanting to do decimals, well, decimals are a little bit tougher. So we got to really kind of think about the decimals here. So let's take a look at the decimals. In decimals, what the easiest thing is to actually make them all the same length. So I look for the two numbers right here, these two right here. They've got 3 decimal places. So I'm going to make each of these other two have 3 decimal places. And then once I do that, I can just treat them like regular numbers. So this is going to become 0.500, and the other one's going to be 0.230. So now I can treat these numbers like 500, 230, 54, 409, and that's a whole lot easier to put in order. Now again, we're doing least to greatest. So which one of these numbers is going to be the smallest? 0.054. Which would be next? 0.23, and then 0.409, and then last but not least, 0.5. And then when you put them in order, you do go back to the original numbers. And that's kind of what we're looking for in this particular instance. Now, those are pretty easy. But what if I give you fractions involved? Okay, well, when we have fractions, we got to actually do some converting. Okay, so this -12 is good. The 3 is good. The -5.5 is good. The -8.07 is good, but -2 3/5? Well, so what we need to do is we need to convert that 3/5 to a decimal. So we do that by doing a division problem. 3 divided by 5, we get 6. So that's going to be -2.6. Then I'm going to do the same thing with the other one. -16 divided by 5. We end up with 3.2. And since one of those numbers is negative, it's going to be -3.2. So write the following numbers in order. So what's the first thing that I need to ask? What order do you want, Mr. Nash? So that would be our first question. Okay, and for the calculator, how would I use the calculator to help? Well, you change your fractions to decimals using that calculator. And now once we do this, I can put this in any order that I want to. So if I wanted to put it in order from least to greatest, I would write it from little to big, or left to right on a number line. Greatest to least, going right to left. So let's just put these on a number line and just kind of make sure we understand what we're doing. So I'm going to put a 0 in here just to be on the safe side. So I'm going to just start sticking them on here. So we got -12. So I'll put a -12 here. 3 is going to be over on this side. -5.5 would be about right here. -8.07 is going to be a little bit further down the road. -2.6 is going to be somewhere between 5.5 and 0. So -2.6. And then -3.2 is going to be right here in the middle of these. Okay, so now that I have these in order, we just write them however we want to. If I want it least to greatest, it's going to be -12, -8.07, -5.5, -3.2, -2.6, and then 3. If I wanted it greatest to least, I just write it the other way. So it's really not that big of a deal. Pretty easy if you think about it in terms of a number line. And typing those decimal or typing those fractions in on the calculator makes it a whole lot easier. Okay, so now we got some vocabulary that we need to understand. Okay, it says define ascending and descending in your journal. Okay, so let's look at what ascending and descending are referring to. These are two types of order that we need to understand the vocabulary. The STAR test has a tendency to use words to describe order for us. Okay, so descending, let's look at that one first because we understand that one the best. To descend, if we were to be on a mountain or something like that, and we were to descend a mountain, that means we're going from the top to the bottom and we're going downhill. So descend means I'm going to go from greatest to least. So if descend means to go from greatest to least, what does ascend mean? Ascend means to climb, which would be least to greatest. So please make sure you have those vocabulary words defined in your notes. So then, this next one says, the golf tournament leaderboard posted scores of -16, 12, -8, 7, -4, and 0. What are these scores in ascending order? So again, we're looking at ascending, and ascending means least to greatest. So we begin using words other than least to greatest, greatest to least, to describe the order in which we are asking for. So if I want these in ascending order, least to greatest, I'm going to take the numbers, place them on a number line, or at least place them on a number line in our head, and then write them down. So in this case, we would have -16, -8, -4, 0, because 0 is part of our number set, and then 7, and then 12. And now my numbers are in ascending order. Pretty simple. It's not very difficult. Same kind of thing with integers. Here's a type of a question that you would see on the STAR test, where they give you the degrees over here, but yet they give you the answer choice based on those cities. So you got to kind of compare that. Okay. Fractions, same kind of thing. This one right here, we're looking for descending, but what's the best type of number to put in order? A fraction. I mean, not a fraction, sorry, a decimal. So what are we going to do with each of these fractions? What would we do with each one of these fractions? We would change them to decimals. So we would do 3 divided by 4, 3 divided by 4, get 0.75. 4 divided by 5, get 0.8. 13 divided by 20, get 0.65. 7 divided by 10. We would take each one of those decimals and then place them in the appropriate order. And again, they're giving you the numbers, but then they're asking you to come up with the answer based on names. So what if we had something like this, where we had square roots? Okay, well, this one kind of gives us the whole gamut of things. So again, in this particular one, we're going to go from least to greatest. So what we have to do is we got to change everything to a decimal. So the first thing we're going to do is 4 divided by 5. So 4/5 is 4 divided by 5. It's going to give us 0.8. Then we're going to do square root of 9. So second square root 9. If you didn't already know that, we know that it's 3. This one's a decimal. The next one's a decimal. So then I got to do square root of 6. So second x squared 6. Enter. Now, that square root of 6 is an irrational number. So because we're just putting them in order, we don't necessarily have to have all of that number, but I do know it's going to be a -2.45. So that 0.449, that 9 is going to bump that second 4 to a 5. So I now have 0.8, 3, -0.95, 2.9, and -2.45. And it says, what is the fourth number when ordered from least to greatest? So if we were to put these in order from least to greatest, okay, the first one, the smallest, is going to be this -2.45, which is the negative square root of 6. Next is going to be the 0.95, so this one's first, this one's second. Okay, and then third would be 4/5. Okay, and then you got 2.9, which would be our fourth number, and then 3 would be our fifth number. So the fourth one's going to be 2.9. So the correct answer would be C. So those are the kinds of things that we're looking for in this particular activity. Now we do have another one here that's kind of an interesting one, a percentage. So what do we do with a percent? Well, we know for a percent, to change it to a decimal, I just move the decimal over 2 places to the left and take away the percent sign. So it's not difficult either. The rest of these are just pretty simple. Now let's look at a couple STAR questions. Okay, now STAR questions may be a little different this year, okay, but they will still have some that are multiple choice. Here's a very typical STAR type question. 2 numbers are shown on the number line. Which value is not located between these 2 numbers on the number line? Well, we don't really know what the value of those are right at the moment, so we actually type them into the calculator. So in that first one there, we got square root of 9 divided by 3. So we type in second square root 9, hit the right arrow key so we can get out, divided by 3. We end up with that value as 1. So this one is actually a 1. So now we got to do 2 pi. So we do 2, and when we shove the 2 and the pi together, that means multiply. So we do second arrow key for pi, so we get 2 pi, enter. We find out that that one's going to be 6.28, and it does keep going. So we want to figure out which one of those values is not in between. Okay, well, we know pi is 3.14 because that's what we know. So we know that one's going to be in between, so that one's good. So it's not the right answer. Well, square root of 9, if you didn't already know it, you could type it in, and you find out that it's equal to 3. Well, it's between 1 and 6 as well, so we know that one's out. So the next one is 9 divided by pi. So we do second pi divided by 9, enter. We find out that it's 0.349. So is it in between 1 and 6? No, it's not. So this one becomes our correct answer. Now this last one here is a squared. So what we need to do on this one is we need to get our pi. So second pi. To get squared, we're just going to hit the squared key, which is the same key as the square root key is. And then we hit divided by 9. And we find out it's a little bit bigger than 1. So it is actually in between there. So C is the correct answer. So when you have these weird things, the calculator does come in handy to change everything to decimals. So what you're going to do today is you're going to do a little assignment for me. Look something like this. Okay, we're going to come back and look at a question like number 4 in just a moment. But there's 6 questions I want you to do. I want you to read the questions and circle the best answer of choice. Okay, so let's go back and look at this last one here, number 29. Because you notice you do have one similar to it on question number 4 on your assignment. So what this basically means, it says which value of x makes the inequality true. Well, what we have here is we've got 1/8, and we've got 18%, and we're trying to find a number that's in between that. That's what that notation means. So the first thing we do is we change 1/8 into a decimal. So we know that's going to be 0.125. And we know 18%, if I find the decimal, it's here at the end. I move it over. I know this one is 0.18. And if we look at it in terms of the same length, it's 0.180 and 0.125. I'm trying to figure out which one of these numbers here is in between that. Okay, so 1 divided by 5, we know that's 0.2. Well, it's not in between, so it's out. 1.6, we know it's certainly not going to be that because that's a whole part. Okay, so it's not going to be that one. 0.09, okay, is that in between there? No, 0.9 is not. Okay, so we know it's out, so that means it's got to be this one down here. So if we actually type it in, second square root 0.02, enter, we find out that its value is 0.14. Is that value in between 0.12 and 0.8? Yes, it is, and there's my correct answer. So that's kind of what you're doing on number 4 here. An inequality is shown. Negative 2/3 is less than W, which is less than negative 55%. So I'm trying to figure out which number is in between negative 2/3 and negative 55%. And you use your calculator to help you figure that out. So this lesson's been about comparing real numbers. And we use our calculator to really help with that. So we convert everything to a decimal and we compare using the decimals. So until next time, I'll talk to you later.